So the R&D UI is the backbone of the CDS UI. So everything that is has been implemented in the CDS has been results of the research performed with the AEGLE platform. But the research user interface was not built with that in mind only. It was built keeping in mind that other researchers with similar interests would like to have more flexibility and not only doing what we have done and repeating or validating our results, but go beyond that or slightly modifying to fit their needs. So that's the overall concept, how the research user interface is built. An outline of this talk, again from the clinician's perspective and the role of big data in ICU, the clinical problems addressed in AEGLE, a brief description of the UI and a little bit more detailed one of the workflows. We're going to see a little bit of that in the visualization, and I'm going to expand some more on the results that we have obtained. Again, why would we do big data analytics in intensive care, and how? Well, the why is obvious. We need to produce new knowledge. As mentioned in one of the previous talks, the traditional way of doing things in ICU is through hypothesis testing and clinical trials. We have had a lot of those over the years, and we have had a lot of failures. It is evident, it is fact of life that we have a lot of information derived from our monitoring and life support devices. And with the advantages in data science, we can now make something out of all this information. We can collaborate with bioinformaticians, with IT experts, and data scientists, and actually have new knowledge from the data we already have. It's been something that the clinicians in intensive care have been increasingly recognized over the past few years. And as an example, I would like to share with you that the current definition of sepsis, you can see that it's a very highly relevant to ICU topic, is based on a data search from an electronic medical record. It was not the result of a randomized trial. We are starting to adapt and include in our practice results coming from leveraging our data. So when we run clinical trials, we try to minimize heterogeneity, selecting and sub-selecting this particular patient with this and that characteristic, a list of inclusion and exclusion criteria. Test one hypothesis, our favorite hypothesis, we put a lot of effort. We're kind of disappointed when it doesn't work, and we're a little biased towards trying to make it work. And because we want to minimize heterogeneity and confounding factors, we end up protocolizing our practice in a way that it makes it almost irrelevant to our actual practice. So we create kind of an artificial environment. As opposed to data-driven research, which embraces heterogeneity, allows exploratory analysis, so it's not like I want to find that one thing and I will, or this effect of this drug, and I will push in any way I can to show that it does work. And it does represent our everyday practice because this is the data we collect, and this is why it is very, very important, and we think this is the way to go, and it's not our thinking only, it's something that is embraced by the scientific community in intensive care more and more. So which aspects of intensive care are more suitable for data-driven research? Of course, we're not going to reinvent the wheel, so we go for the unresolved issues, but we have so many, so don't worry, we're not going to run out of any. We will have to focus on sufficient data, and here it comes some issues mentioned before, and some are really addressed or focus of the EU now, how we're going to have more uniform electronic medical records so we can actually advance the science in this field. I think this is a very, very important issue, and we need the EU to really push towards this direction for unified coding and electronic medical records that make sense to the data scientists. Anything that is continuous should be addressed with the help of computers, since we are not 24/7 looking at one parameter. We have many patients, many factors to look. Anything that is multifactorial and heterogeneous, that covers pretty much every single patient and aspect of intensive care. Again, with AEGLE, we have focused on mechanical ventilation and nutrition. Why? Because we think that there is a lot of room for improvement there. Mechanical ventilation, and specifically assisted ventilation, is perhaps the most neglected part of the very basic intensive care supporting therapy. It's very difficult to address because things are changing all the time, and so we need continuous recordings, and then when we have continuous recordings for several days, we cannot analyze that, and then we need the data scientists to help us do that. And nutrition, because, well, after feeding patients for about 50 years in the ICU, we still don't know how exactly to do that. And we do have enough data to address this issue. So, again, some issues while working on this subject during AEGLE. Safety, most important. I think there has been a very large amount of person months spent in that. I think we provide a very safe environment for data to be stored and handled within AEGLE. State-of-the-art cloud technologies that allows these analytics to be performed and data queries to be performed. The platform allows predefined analytics. I'm going to discuss and present what we have included there, but allows for code upload, so custom analytics can be come and complement what we have already done. So a new researcher with a research interest that is close but not identical to mine can perform an interesting work. And accelerated analytics. So, as I said before, the CDS is what has come out of this research platform, and this is meant only for the clinician. This is a little bit of the structure, and although I have learned a lot of new words while working with the technical partners throughout this project, I'm still not the appropriate person to describe this complex infrastructure, so perhaps Yorgos would like to briefly walk you through that.
This is an abstract overview of the AEGLE's backend. AEGLE consists of actually two clusters. The first one is what we call the software clusters, that comprises only regular machines. And the second one is the accelerator that has the accelerated classes that has regular machines and also hardware accelerators that are actually Macella's machines that have FPGAs to accelerate your application, your functions. And these two clusters are federated so they can communicate with each other. So when you have a fully software application, you run it on the cloud software-only infrastructure, and if you have an accelerated execution, then data are transferred from this cluster to this cluster, the accelerated execution is performed, and returns back the results. Actually, these clusters are quite replicas, but since this one is hosted in a cloud provider, you have like infinite resources. So you can exploit this to scale your software resources as much as you need and as much users as you have. And since this one is a private cluster, you have limited resources. And actually, to efficiently integrate these two clusters, we have created also an aggregated software hardware resource management in order to orchestrate and schedule the execution of all the applications. We use state-of-the-art technologies. Everything is Dockerized, so you can deploy the AEGLE platform wherever you want, in your hospital, in your company, in whatever cloud provider, Azure, Amazon, Google. And we adopted an orchestrator in order to manage and orchestrate all the applications. And we have some basic components, the MySQL cluster for storing the HR data, and HDFS for storing raw data files like DNA sequences, images, and signals from the ICU. And FeedHR is a component developed by Nutritional partner in order to upload the anonymized data and provide permissions and authorization checks over the EHR data of the database. Actually, we have Spark for executing the software applications, and all these components can scale out and in based on the needs. So when you have a lot of workloads, you scale out, and then when your workload is decreased, you scale down so you don't have to pay for extra resources. And of course, we support running third-party tools like RNA sequencing or DNA sequencing that are well-known tools and highly adopted in the respected scientific domain, and all these executions are managed by the orchestrator, and you can deploy them on demand. Read the input from the HDFS, run the execution, software on your accelerated only, and that's it.
Of course I could say all of that, but you had to talk. So the data types from the ICU included, and similar data types anyone can upload and analyze. Data from any patient ventilator interaction monitoring device, data from commercially available ventilators, and electronic medical records, as well as basic monitoring, bedside monitor data. We have, our library consists of 2,000 patients. So this is an outline of the R&D UI. We can have the workbench here. We're going to see. We have the analytic toolbox that one can take an overview of the analytic tools available. There is the ability to upload data or upload code, and we're going to of course, visualize, see the analysis result and then visualize them. We're going to discuss a little bit about the workflows, the predefined workflows that we have included. And it's about the ventilator. I'm going to discuss the nutrition and patient deterioration and patient-ventilator interaction. So starting from this last, the analytics available for the patient-ventilator interaction monitoring data include the feature extraction and the causality analysis. This, as any monitoring data, come with gaps, with missing data, with false entries, and there's a pre-processing step that formats the data in the way that they're meant to be for analysis. There's the identification of ineffective effort events and the extraction of their features, wavelet analysis for causality, exploratory, and the mortality predictive analytics. So we are going to show you now a little bit how this looks on the UI. So different, I'm going to select a patient. This is a workflow, so steps of analytics going from one to the other. Because we wanted to allow some flexibility, we have defined the ineffective effort event in a certain way. So, for example, we apply a smoothing average filter of 6, but someone may want to explore a little bit further or differentiate from our current proposal. So we have allowed flexibility in several parameters, so one can explore the data in a little bit different way than ours. I think it's important in research when no one wants to exactly always replicate another person's work. They want to play around a little bit. So when we have generated the workflow, we run it. It goes to the workbench, where we can see whatever we have been running. And we can visualize our results. In any results that we take, because this is research, most important is the tabular format that we are going to get our data, and then we're going to do other analysis that we had in mind. But visual exploratory analysis is always important, and first, especially at the initial steps when we don't really know what's happening and we want to see what correlates with what and just get a visual of it. So we can, we have the ability for the user to create plots. So in this case, a meaningful plot would be to see time series. And in this time series, we would see the signal of our interest, in this case, the ineffective efforts, here selected in the first panel, and how it changes to another signal that we think could be involved in the cause of ineffective effort. So I see here this patient does not have many ineffective effort up to that time point, and then he's having a lot at this, and I have this other signal. So if we zoom here, we can see, is it caused by a change in this parameter? Well, I don't think you don't really know what, you're not expert in this field, but you can see that this significant change in this signal is not related to a change in this signal. So we're going to look for something else. But this is the idea how one can, when you don't have a clue about what is happening, you can start exploring and looking for interconnected parameters. Again, going back to mechanical ventilation, as discussed already in the CDS UI, we have been working a lot with this driving pressure, the pressure descending the lungs at inspiration, a significant parameter causing ventilator lung injury, the way we can hurt our patients with our ventilators. So we collect data from a commercially available ventilator, the Bennett one, and we have pre-processing because, of course, ventilator data are not completely clean. Sometimes the nurse disconnects the patient, sometimes the patient is coughing, so this is not really breaths, it's other type of signals, and we don't want them in our analysis. So there's a pre-processing stage. We calculate the driving pressure, although this is computed based on data coming from the ventilator. The company had not included this in their software, so this is only available through our software. And because we want to interfere and we want to analyze stable periods, not when something is rapidly changing, because at this point these connections are not so meaningful, we identify the stable periods through our analytics, and we characterize them with some basic statistics, and we further characterize and identify periods with what we have shown to be abnormal values. So using this analytics, we have analyzed some hundreds data from patients, and we have identified some thresholds that are related to worse patient outcomes. So we can provide analytics exploring these thresholds, but also, as I showed you before, an investigator can modify these thresholds and obtain results on different thresholds or parameters. We have developed an analytic that predicts the development of high driving pressure, and this is also applied in the CDS as I showed you before. And because one may want to investigate what is happening in terms of physiology, and it gets a little bit complicated here and a little bit medical, but please stay with me. If we combine two signals, one from the ventilator and one from the monitor, we may be able to use the analytics engineers can provide us, so clinicians are not very familiar with. We can get an intuition on what is causing what. For example, if the patient is stressed for some other reason, that may be indicated in his heart rate, so heart rate increases. If he's stressed, he may start breathing difficultly. And we may see a change in this driving pressure. So if we look at those two signals together, we will see this signal of the heart rate increasing first and the signal of the pressure increasing second. So in this case, we can assume that there was a stressful event in some other part of the body. Something else was stressing the patient and was reflected to his breathing. If something happens on his lungs, then the pressures will increase. That will cause stress to the body, and the heart rate will eventually increase. So we will see the signals changing again together, but at a different sequence. So such type of investigation can provide insights in what causes these events of abnormal pressures and how that would be better explored and addressed eventually clinically. I will, the data from the Bennett monitor, I show you some graphics in the CDS UI. The analyses are quite complicated. We get some tabular formats that we further analyze, and of course the user interface provides these tabular formats, but I did not include them for display here because there are just a lot of numbers. So going to nutrition and exploiting the vast amount of electronic record data. Here there are a lot of missing values. We forget to put the thermometer, or the thermometer is on the bed instead of on the patient. It shows 24 degrees. The pulse oximeter is off. There are a lot of missing values, so there's a lot of pre-processing for the electronic medical record to make sense. Calculation of nutritional parameters also requires some computational input, because intake has to be formatted from formula to contents, proteins, minerals, vitamins, and such. Needs are personalized, so they are derived from algorithms that take into account patient instant temperature, breathing rate, whether he's on mechanical ventilation or not, what is his basic condition that brought him in the ICU, so it takes a lot, and eventually the deficits are computed. When we want to investigate nutrition, we cannot do one size fits all, so we need to adjust our research, and we have to have some input or confounding factors, other parameters derived from hospitalization, like organ failures. Patients with a kidney failure are not the same as patients without a kidney failure, or with or without renal replacement therapy, that significantly affect nutrition. Severity score, you cannot compare a patient who came post-operatively very healthy and with just an increased heart rate or something with a patient who had just suffered a major trauma. So we need to adjust this in our research platform, and we have included some of the predictive analytics. We have included the predictive analytics that we have developed, but this is, I think, the area of most active research that one would want to use their own data and form their own research questions to get answers in a specific population. This is why in the CDS we have allowed the user to modify the threshold, because we believe that if you use both, you can investigate your specific patient population. For example, it could be a surgical ICU where they have only trauma patient, or a neuro ICU where they have brain injury patients. These patients one could see in her research that the threshold for optimal nutrition is X, as opposed to mine, which is something else. So you would apply that to the CDS of your unit. And of course, we have visualizations that you have seen, some of you saw yesterday, and apart from the basic time series, there are heat maps, there are box and scatter plots or parallel pie charts, and of course, numbers, because eventually we work with numbers when we do research. One can add custom workflows, but also custom visualizations. We will show you some very basic box or scatter plots here in a nutrition example, but there is a lot of flexibility because that's what research is about. So just here that was the previous work that we ran. It was completed successfully, but we can see now a work for some visualization from nutrition. So let's say that one wants to explore the hypothesis that the more severe a patient is on admission, that's indicated by an Apache score, the worse he will do and the more, the higher his deficit in nutrients will be. Because when you're really bad, you don't receive food. This hypothesis is not supported by the data, as you can see here, because in the x-axis, I see patients with a very low severity score and some high deficits, while patients with a very high severity score have really low deficits. So this is just exploratory. It's not meant to show you a result. It's not meant to show you an outcome. It's meant to show you that this is an area of research, and the researcher has a lot of flexibility to explore, because we really need to do a lot of research on nutrition, how to properly feed our patients. We can also have, for example, a box plot to test some other hypotheses when they said, dual bivariate components. So let's see if we see proteins. And so it has been speculated that when we put patients on non-invasive ventilation, this is a big face mask, that we don't feed them, so that's not really good for them because they starve. This is not supported again here by our data, showing here that the deficit for the patient who received or not received that intervention was not really significantly different. And when we do such work and we find an interesting result, we may want to save it or use it in a publication, and this is also a feature provided. So we hope researchers will be able to get interesting results using this platform. What we have done using AEGLE. I have already discussed about the results of our patient ventilator interaction analysis. We have used the tools developed within AEGLE to identify the ineffective efforts, the clusters, and we have been successful in convincing everyone in this field that this is the way that things should be done. This is a fact of life. Things happen in clusters. So one should analyze like that. This has been accepted by the scientific community. So this is a work supported within this platform. We have also been able to introduce the concept of monitoring driving pressure during assisted ventilation, and this has also been welcomed from the scientific community with great interest. And we provide with this platform the ability to monitor and predict high driving pressures during assisted ventilation. This is also of interest to the scientific community, but also to the company that produces this ventilator. And finally, we have done some research on the nutritional deficits of mechanically ventilated patients. As I show you here, this part is open for a lot of research and for customization. One should use their own data to get information about the patients in their own department, because this one-size-fits-all concept is really not working for us. It hasn't been working for several years, and we have to abandon it. And as I said before, the CDS relies on the results and can accommodate results developed through the research user interface. We will soon provide demo data from real patients that you can use for a demo, and which you can ask using this link. So I will stop eventually, and thank you. Take any questions.
Thank you again for both presentations. And our next...
No one wants to hear me talking anymore.